For the Fibonacci sequence, the first thing that you've got to realize is how the Fibonacci sequence works. And the way the Fibonacci sequence works is you start with two numbers. In this case, you'll always start with 0 and 1. Now, so we have two starting numbers, 0 and 1. And then what you would do is you would take 0 plus 1, and that would give you 1. You then move to the next two characters, and you would add those two together, which would give you 2. You then move to the next two characters, which would give you 3. The next two characters, which will give you 5. Now, as it's moving up along there, Okay, so now the question is, how do we get the computer to do that? Now, obviously we would say X amount of times, so we want it to happen like, let's say, 12 times or 5 times or whatever it is. You would want it to have that many times. So what you would do is you would create a variable to store the starting numbers. And you would create a third variable to have the next number. So you'll just say Z is equal to X plus Y. Now if you take a look, if Z is equal to X plus Y, that would mean this would become 1. But now what do we want to happen now? We want X to become where Y is. So we want X to equal Y. And we want Y to equal to Z. Now if we did that, that would literally do this, wouldn't it? It would make Y equal to Z. So that wouldn't be, damn it. That will move over to there. X will become Y, which would be, we'd have to do before. So X would have to become Y, and Y would become Z, and then Z would equal to X plus Y, which would become 2Z. So literally all we're doing is we're just moving everything up 1 each time. So we're just saying Z is equal to X plus Y, X is equal to Y. You could probably do it in this order over here as well if you wanted to. The order of this doesn't really matter, but it's the way you would loop it that would make a difference. So that's all you're doing, is you're literally moving it up. So now Z is equal to X plus Y, which would become 3. You then move everything else up. So your X and Y keeps track of the two ones that you're adding together, and then Z would just always be equal to those two added together. In this case, would be 5. So all you're doing is you're starting with X and Y here. You then make Z equal to the next one. You then start with X and Y moving up 1. And then you make Z equal to X and Y plus each other. Do you guys follow the logic of the Fibonacci sequence? So now we actually got to physically put that into Scratch language. And in Scratch language, first of all, we need the number of times that we want to loop. So I'm going to say there, control, sorry, not control, yes, it is control. We want to loop, repeat, and I want it to repeat between 5 and 15 times, or whatever it might be. And this means this will actually occur 5 to 15 times. But the first thing we need to do is we need to keep track of our variables. And our variables that we have is we have X, we have Y, and we have... Oh, I just made a list. My bad. How do you delete a list again? Oh, there we go. Look at that. Okay. So I'll make a variable X, Y, and what's the last variable we have? Z. Now, what does X start at?
0.
What does Y start at?
1.
So remember, you always give starting values. And what does Z start at?
1. X plus.
X starts at Z. Sorry, what does Z start? Z starts at X plus Y. So I'm just going to go. Obviously, technically, this is 1, so I could potentially just put it there. But just for logical sake, I'm going to put this as X plus Y. Now, I want to then, depending on how we're doing this, I might want to display all of these answers directly at the end. So I actually forgot to record the cursor, so things are just magically moving around without actually seeing the cursor moving in. But if, for example, I wanted the whole sequence to be displayed at the end, I would create another variable called display. Now my display variable, I would set display to be operator join, and then I'd set display to be X, comma, Y. So it will start off with 0, comma 1. And inside here, I would repeat this. But all I would do is I would join, comma, and fail. Do you guys understand what this part is doing here? With display to join, display, join, comma, and y. No. Okay. Basically what's that doing is display, okay, to start off with, display is join x, join, comma, and y. Which means x, what is stored in x?
0.
I actually want to split this vertically, but I'm thinking it's going to go crazily. Whoa, got way too much stuff open. Minimize, 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 minimize. That's not cool. Where's my Excel gone? Here's my Excel. Okay, so let's say in this case, here we have our variables over here. I'm going to hide this weird screen, or at least make it smaller. And here we have our actual code. Now, one of the things it says display. So I created a variable called display. And the first thing I've said there is I've said set display to join x, join comma, and join y. So let's keep track of all our variables. We've got x, we've got y, and we've got z, right? So first of all, I set x to 0. I set y to 1. I set z to x plus y, which is 1. Then I say set display to join x, comma, y, which is going to make display what? 0, comma, 1, because it's x, join a comma, and join a y. So join just appends the text. So display is going to be that. But now it says, the next part, it says loop, it's going to pick a random 5 to 15 times. Let me pause quick.
Single line saying 0,
Yeah.
1, 3, 5.
So the reason why we're using display is so we can add it to one variable and just say one variable. We don't have to say 0, 1, 2, 3, whatever. We can just say 0, 1, 2, 3 rather than saying each individually. We can say the whole lot. So the next line, it says there, display, join display, and, sorry, it should be z here, with a comma z. So that's just going to add on to it 0, comma, it's just going to add on to display the z. In this case, it will add on 1. Now what do we want to happen? We want to move x to be the next position, which in this case would be, we want x to be, what do we want to set x to be? What value do we want x to be? If we're looking at, sorry? 1, but not necessarily to 1, it should be?
Y.
It should be y, yes. So I think I did hear someone say that, but I didn't hear properly. Okay, so literally we're moving x up to y and y up to z. So we're going to set x to equal y. We're going to set y to equal to z. And then we're going to set z to equal to
X plus Y.
So it's just
x plus y. Now, and this will loop however many times it's going to be and display z each time. So if we go down to our truth table, remember this is called the truth table down here. I'm actually should hide this thingy so we have more space. Now for our truth table, the next step, so if we now go down, x is equal to y, so what does x become? 1. Y becomes z, what does y become?
What? 1.
1. What z is equal to x plus y, which is 2. Display is, so this would loop around again, because it's looping however many times it's going to loop. And display is equal to display, comma z. So display is going to be what display is. So display is 0, 1, 1, 2. Do you guys get this?
Yeah.
Sorry, there shouldn't be a space here because I haven't added a space anywhere. And the next one is going to be, so x is equal to y, so what is x going to be? 1. What is y is equal to z, so what is y going to be? 2. And z is equal to x plus y, what is z going to be? 3. And display is equal to display plus z, which will be 0, 1, 1, 2, 3. So you see, each time it will loop around, it literally appends whatever it was on z to there. And then eventually when it exits, z is going to contain the next value that would be added to display. So now when we ask the user, we're going to say, ask user, what comes next, and we're going to display to them, oh, that's a stupid place to put that. Stop rocking on my chair.
Sorry.
You nearly lost your yes. So we're going to literally join what comes next? And then we're going to, what was the shortcut for an enter? It was Alt Enter, right? Or was it Control Enter? Okay. What comes next? And then I'm going to join my display to it. And then we're going to wait. And we're going to see if what the user entered, sorry, if what the user entered equals Z. So if sensing answer is equal to data Z, then we're going to say jolly good show what. And otherwise we're going to display that's not cricket. That's not cricket. Alright, so now if we go and we do this, I'm just going to delete this because it's not needed. If we now run this, let's test it. Okay, 0, 1, 1, 2, 3, 5, 8, 1. Oh, sorry, 13, 21, 34. What does come next after 34?
55.
55. So if I go 55 and tick, it should tell me jolly good show what. So you check the Fibonacci sequence has worked. Now, the difficult part here is keeping track of your variables, the fact that you've got X and Y. But if you follow it like this, you can keep track. It's going to loop around, and Z happened. We change Z, we add it to the display only at the beginning. Order of events is important. It's quite difficult to explain order of events, but it's something you need to pick up on. And okay, this is what happens, and this is what happened. And one of the good ways of keeping track of that is with the trace table, and going and saying, okay, what would happen next? Next, this would be X, Y. X would become Y, which would be 2. This will become 3. This will become 5. This would then become 0, 1. So if you follow the trace table, you can logically understand how the program is being run, and that's why trace tables comes in handy. It lets you follow what's going on there. Yeah. There probably are alternative solutions, but not that I know of that's elegant. There might be unelegant ways of solving it. I've never seen another elegant solution to this. I'm going to end this video here because that's Fibonacci sequence done. Goodbye.